Greetings, welcome back to CS133, Practical Programming with Python. This is week 7, Robotics. We're going to sense using the SenseHat. And we've played with this a little bit before in other lessons when we're using our imports. But this is kind of where we're going to be able to actually interact with our environment, right? That's really what robots do. They interact with the environment. They need to be able to sense it, right? So we'll go over the actual Raspberry Pi and SenseHat. So if you happen to have one, you can follow along with that. Otherwise, it'll be a good understanding what it is. Otherwise, what we'll mostly do is use the online editor, and you can do the rest of everything you need to do with the online editor. I made sure of that. But again, if you do have a Raspberry Pi, we'll go through some of that stuff throughout this lesson. So our objective for this lesson is to introduce students to creating a full project, right? We want you to actually, and in this case, the ideas already be there, but you're going to have an outcome that you need to achieve and then work your way through it. Again, this is step by step. It's going to walk you through it, but with a goal of eventually leading you to doing this on your own. And also, as we talk about the SenseHat and go through some of these little practices, having you come up with some ideas of stuff that you might want to do for your project. Our success criteria is you'll demonstrate completing a project that randomizes lights on a SenseHat. Again, we'll talk about that a little bit at the end of this lesson. But let's kind of jump into, again, SenseHat as an actual device with the Raspberry Pi. We'll go over the hardware, the emulator, the web, which the web we'll go over later. We'll do that, but we really want to talk about the hardware and what's on it, what it can sense, and the web emulator does all of this, and we'll talk about some nuances of that as we go through. So this is the SenseHat. Again, if you have one of these, this is what it looks like, and this points to where everything is: the gyroscope, accelerometer, magnetometer, the 8x8 LED matrix. Which again, you can program each of those individually, 0, 0, 7, 7, temperature and humidity sensor, biometric pressure sensor, and this is actually a mini joystick with a button, so you can program Mario or something like that on it. Now, it was originally designed as the AstroPi to go in space, so this case, from what I understand, is a $10,000 case on like a $20 computer. But you can go to space, and I guess if you live in Britain, you can actually send code up there that they'll run in space. Now, there's the software emulator, so you actually run the Raspberry Pi, and you don't actually have a SenseHat on it. You can actually emulate it and actually have your Raspberry Pi run this program. And sometimes students will do that to test it out, so they're not using all the sensors. It gives them the toggles so they can actually change the temperature, which is hard to do because you'd actually have to get the device hot. So they might run as emulator, and it's really easy to switch back and forth. And then, of course, we've seen Trinket, so we'll use that after the presentation. So again, as we're going through this presentation, you can pause at any time, type in the code. But all of this code is actually exactly the same as the Raspberry Pi and for the online code as well. So if you want to go ahead and try this at SenseHat, you can do this. Just make sure to delete all the code. When you type in the front SenseHat import SenseHat, that tells Trinket to go ahead and do that. And then we've talked about the rest of this before. This is their standard import. We take all the SenseHat commands, put them into Sense. You've also seen it just as S. And then if you run this and show message, it'll actually say Pi Academy across this. Again, if you have a real one, it'll literally light it up. Whereas if you do this trinket.io as go. If you are on the Raspberry Pi, you need to open up Python to do this. So you can just go in to the top corner of it and open up Python. And again, it would be up here. Open up Python and type this code in. You need to save it and then run it. If it opens up, depending on which one you open up, some of them allow you to type the code up front and then up top and then run it below. Some of them require you to actually create a new file, type it there, save it, and then run the file. Either way, you can Google how to do that, run Python on your Raspberry Pi. This is the code to get it to go. So If you want to just display some colors, again, we have our from SenseHat import SenseHat, and we're also do some sleep. If you remember what that does, that allows it to pause. So again, we take our SenseHat commands, put them into Sense, so it'll make it easier. We come up with a color. When we saw this before, but if this is a variable, we can call it whatever we want. This happens to be the code for red. It does need the parentheses, so 255, comma 0, comma 0 is red. Remember RGB. And then and this is how it works, sense.clear clears the screen whatever color you send it. So basically this will make a big red screen. If you don't actually put anything in the clear, then it will blank it out. So sense.clear with a color, we'll fill it with whatever color you have. And again, you could have turquoise, whatever you want. You just have to find the RGB code for that. And then if you want to do one specific pixel, you can do sense.setPixel and then location. Remember, it's 0, 0 as a top corner, so this is actually 5 over and 6 down, right? And again, you got to remember the orientation of your device, and then it'll make it red. So again, pause if you need to, try this out, see if you can get it to work, and we'll move on to displaying emojis. So instead of just doing one pixel or setting the whole screen to one thing, you can actually, again, put it. So in this case, they're just red and white. So R and W, and this is what a lot of people do to make it a lot easier, especially for making this. And we'll have an example in our second lesson of going over this with a little bit of project planning, so you can plan out what you're going to do. But as you can see, white, 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 red, red, white, 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 red, red. This, and you can kind of even see the question mark here. This draws it. So what I recommend is when you're placing this, don't do the question mark. Make your own, and you can make any colors you want. So if you want blue equals 0, 0, 255, right? And then to actually get it to take this, so this is an array, right, a list, you're going to set pixels. And notice, remember, the last one was set pixel. That was one dot. In this case, you're going to do set pixels to get your question mark, and it'll take this little list and create that. All right. Again, as we're going through some of these pieces, think of ideas that you could want. Piece of these can interact with each other. So you can take readings that we're going to talk about, the pitch, the yaw, the roll, and then you can make something show up, right? What do you want to be able to do? Think of something practical that you might use it for. An example we had it before was it took the temperature readings of the room, humidity, and it would post warnings if the room was too hot for a certain plant. It was all programmed into it. So again, things that you can do. So you can see which way this twists. And we'll just use terms. You twist it sideways, side to side. That's the roll, right? If you go up and down like this, that's the pitch, and then the yaw is just it's tilting. If you ever seen an airplane, this is kind of an easy way to explain it. As the plane's going, when the wings tilt down, that's the roll. As you're lifting off, right, that's the pitch. You're tilting up, and then you probably have seen this, but not really recognized it. But if you ever seen a plane coming in for landing, and it's not actually facing the runway, it's kind of coming at an angle because of the wind. It's fighting the wind. That's the yaw, right? It's not actually going forward, straight. It's going along with the runway, but the plane itself is not actually following the runway, right? That's because the yaw has to twist a little bit to make up for the wind speed. So how do you get that? Well, we need to add a little bit more code, although we still have our SenseHat, whatnot, but we need to get the orientation. So when you get the orientation, it actually has a bunch of different information in that, right? So when you get this orientation, it has more data in it. So that's why they labeled this variable data. Now you can get each of the different pieces of it. So the pitch, the data brackets, square brackets, pitch will give you the actual pitch. So this variable is the actual pitch. Now, if you do a little loop, maybe for I in range 100 or whatever, you can actually see what the pitch is as you're pitching it. Otherwise, if you run this program, you'll get the pitch, and you have to tilt it, and you have to run it again, and tilt it, and run it again. If you give a little for loop in it, and maybe in a little sleep statement, that's why they import sleep a lot, you can tilt it and kind of see the different modes. And this is useful. This is a very useful feature when you're trying to actually figure out your code. Like, how do I know when it's tilting too much? I heard of one project program where they actually had the SenseHat was trying to check the water levels, but what they came up with was they had the floaty in the water, and the SenseHat, like kind of like leaning against the float, and when the water went down, that would make the SenseHat tilt down. So they needed to figure out what the tilt was when the water was too low. And again, this print, there are lots of times where you will print something just to figure out, what it is at the angle. Sometimes, it might be 0.9, it might be 100, right? You don't know what that is. So sometimes printing will let you know what it is. There's a lot of these as you go through on these projects that need this concept as well. All right, and again, put in a while true, and it'll go whatever. You can also use sleep. I mentioned that before. So anytime, pause this, go back, you can type the code in. All right, other commands that you might run into: get temperature, get pressure, get humidity. Here is a whole bunch of other commands you can go to as well. And that's about it for using the actual SenseHat itself. In the meantime, let's go ahead and we'll do a couple practices, and then we'll talk about the random project. So we already have all of our import commands. We can create our color. Again, green equals, we need that parentheses, and remember 0, 255, 0, goes RGB, that gives us the green. And then I'm going to do a for loop. And we can do a while loop. It's going to run forever. So while true will make it run forever, right? And this is, normally what robots do. They run forever unless you shut them off. So we're going to create an if-else statement showing the temperature is the correct color. So we need to get the temperature. So if S, right? And again, we used S in this case, not sense. Let me actually make that bigger for you so you can see it. So again, we use S, not sense, so I can access it. S dot. In this case, again, we're looking for the temp, which happens to be temp is greater. And do notice that this temperature is in Celsius, so 100 degrees Celsius is actually the boiling water, right? But we're going to go and use that because it's easy enough to use. If the message, we're going to show a message. And again, here's something to understand, and I already did this. Now you can get the temperature up here, temp equals s.temp. But one problem you're going to have is if you don't get it again, this temp right here is always going to be the first temp it runs. So right now it's at 98. So when I run this program right now, it'll be 98. When I come here, it'll be 98, 98, 98, 98, right? It'll never get greater than 100. Even if I pull this, it's still 98, right? It didn't update. So that's why if you do this s.temp, it updates your temp. So this is a big thing you need to watch out for. I see a lot of students not update their temp correctly and do this. All right, so if the temp's greater than 100, we're going to s.show message. Remember, it's a string. It's hot. Oops, spell hot right. Enter. Else s.show message. Not so much. All right. So again, I'm going to first show you this like this, right? So I'm going to put it under 100, so it should say not so much. Right at 100 errors, so you can see. I'm going to change this to a SenseHat. Since that's what, if you have, that's what you have. So not so much, right? Not so much. Now if I put it over 100, now you do have to wait for it to finish, so not so much. And now it's going to come back up to here, but temp is still that 70 degrees we started with. So again, that is why I did s.temp, this is going to re-get the temperature every single time. So let's stop and so when we run this, it's over 100 right now, so it's going to say it's hot, right? So it's hot. And then, again, I'm going to put it under it now, so it's going to finish it's hot. But as soon as it finishes that, not so much. So again, now this is just an example showing a message, but we can do all kinds of things. I mean, we can make it play a beep. If you have an actual Raspberry Pi, we can make it show a sad face, happy face. You know, there's all kinds of different things you could do to get it to interact with that system. So for the purpose of this, if you want to do a color, I believe you do text color equals green, and this is if it's hot, it'll be green. Oh, not even over. One other thing too, it tends to break if you completely max it out. I don't know why, so be careful about that. There you go. So text color green, and it got green because of this. All right. That is an example of interacting with it, right? We can get the temperature, but you need to re-get the temperature. We can show message. So what I want you to do is go ahead and do this, recreate it yourself using humidity. Now, in this case, I want you to actually show the humidity, right? So show the humidity in there. So right now I showed a message. Right? I showed a message. I want you to show the humidity. But remember, the humidity, which is just dot humidity, to get it, s dot humidity gets it is an integer, right? So you can't send an integer to this. If I do s dot temp, it's not going to take that, right? So as an example, so again, I'll let you work on that. That's your thing for that. You can pause here and work on it, or you can just finish up. What I'm going to show you lastly is this mini project sparkles, and you also have this in Canvas. But basically, your end state is you're going to make a little sparkle thing. So in Canvas, you'll have a link to the project file. You'll fill that out. There's some questions at the end. There also has you change up some stuff. So pretty much you're going to follow along with it step by step, get it to do this. So you do need to think about what it's doing, right? This is not perfectly step by step. It's going to tell you to first add a color. Then it's going to randomize the color. And you're going to have to understand what it's talking about. And again, remember, it's 0 to 7, so when you randomly pick a spot, it's 0 to 7. So those are some of the key things I see students not understand is, and again, you can randomize the colors. Remember, it's RGB, so you can randomize 0 to 255, 0 to 255, 0 to 255. You can randomize all of that as well with importing random, and you can make a completely random, then you can speed it up with the time. Follow along with that project. You're going to turn it into Canvas. If you have any questions, post them to Canvas, and we will see you next lesson.